Let's take a look now at the most simple Gauss quadrature formula. Remember what we're talking about are in-point rules? Well, we're going to take the one-point rule. The one-point rule says you should estimate an integral from a to b as some constant times f of, now x1 is just going to be some number in between a and b. Now how do we choose that? We've got two basically unknowns, or things that we want to produce that give us a reasonable estimate of an integral. So we're going to have to find C1 and C2. Well, when you have two unknowns, we're going to use a linear estimate, okay? Two coefficients, in other words. So let's just say that this is the equation of some generic line, and I know how to produce the exact integral of this. We could say the integral of a0 plus a1x dx from a to b is equal to, let's see, a0x plus a1 over 2x squared evaluated from a to b. And I'm going to look at my notes here and make sure we get what this is. This would be a0 times b minus a plus a1 times a fraction so this is the exact value of this integral from a to b. Now, from this Gaussian one-point formula, I know that the integral of f of x is, let me write it down again, from a to b. We want that to be c1 f of x, f of x1, which is c1, well, we're going to choose our x1 between a and b, but f of x1 just gives us a0 plus a1 x1, which I'm going to write as c. I'll write it like, yeah, I'll write the c1 first, a0, just distributing the c1 through. Okay, so what I want to do is set this equal to this. And we'll be able to figure out what C1 and X1 are. So let me use a different color here. Notice that B minus A corresponds to C1. So if you think of A1 and A0 as being the coefficients, the A0 maps up there, and then A1, this is going to be tough, but this number, or expression, corresponds to that, because A1 is just that coefficient. So that's how we're going to figure out exactly what to do. We're forcing the coefficients of A0 and A1 in both of these equations to be equal to each other. So then, C1 equals B minus A. And the other one, C1x1 is equal to this b squared minus a squared over 2. Well, I want to figure out what x1 is. So here's c1. But if I want x1, c1 is b minus a times x1. c1 is just b minus a from above, substituting, equals b squared minus a squared over 2. let's see, if we divide both sides by b minus a, remember that b squared minus a squared is b minus a times b plus a. This is the difference of two perfect squares. We get x1 is equal to b plus a over 2. So, to summarize the one-point rule, the one-point rule gives us the following. The integral from a to b of f of x dx is approximately equal to c1 f of x1, which is b minus a times f of a plus b over 2. And if you think about it, that makes really good sense. If you don't know what the function integral is, and you're wanting to get a very, very simple, rough estimate, just choosing one point, you take the integral as being the interval width, b minus a, and then you take the height associated with what? This is f of the midpoint of a and b. So sometimes it'll be accurate. Probably half the time you'll overestimate, half the time you'll underestimate, but it's a very, very simple formula.